Try writing a piece of code for binary search, but let's use recursion. Using recursion. Okay. How do I go about this? Let me think. Firstly, let me zoom this. Okay, increase the font so that it's clear to you people. What should I do? I should define my recursive binary search. I'll take L and K. All right. What should this do? This will recursively help us recursively compute binary search. Okay, so how to go about it? Let me just think. Again, the same old list. I'm going to have it, remove one part and retain the region of interest depending upon what the middle is. Alright, so recursively speaking, all I'll do is let me think. So I'm as blank as you people are. I'm trying to build it from top down. I know by top down I mean I have a big picture. I should slice it down into smaller details. So what I'll do is binary search of an element k on this is same as binary search of element k on one half of it after discarding this. So this was begin end, and begin end becomes this. The list should not be replicated. The same list goes in L. Okay, but then I think I should include begin and end here is what my mind says right now. If your mind doesn't say it, you don't include it, but my mind says begin and end, the region of interest should be here. Okay, to begin with, begin and end will actually be 0 and length of L minus 1, but with time it becomes smaller and smaller. So what do? I should first consider the trivial cases. What are the trivial cases? That's very easy. When if begin is equal to end, the region of interest will simply be nothing. There's only some. Begin is the same place, end is the same place. If in case, which means these are all discarded. Okay. If in case element k is there, it must be here or nowhere. Right, I'm being a little fast because we should be real fast now because we have spent a lot of time discussing the trivial codes so far, which today is trivial for you people, but all this while it wasn't. So from now onwards I'll go a little fast. Alright, so all I'm trying to say here is if begin is equal to end, I need to simply check if L of begin is equal to k. If it is true, then I'll return 1. Otherwise I return 0. That's it. Case over. Right? This is when begin is equal to end. Okay, begin and end is the same, then this happens. What if it is not true? If begin if end minus begin is equal to 1. Okay, if end minus begin is equal to 0, that's what this means, right? When it's equal, end minus begin is 0, this happens. When end minus begin is equal to 1, what exactly does this mean? This simply means that we have begin here and end here, continuous terms. Our region of interest is this, and we have removed the other regions of interest. Let me just change the ink here. This is not a region of interest. This is not a region of interest. You are only concentrating here, right? So then you should find whether k is here or not, or k is here or not, and boom, you are done, right? So as you can see, I'm thinking very slowly. This might be confusing for you people as this keeps popping error. That is because if your code is incomplete, it keeps showing syntax errors. Anyways, let's ignore it. So because our code is not complete, so let's go ahead. If end minus begin is equal to 1, then I should check for if L of begin is equal to k, then it's true, or if L of end is equal to k, because there are only two regions there. My region of interest itself is only begin and end, only 2 points. In between there is nothing. Why there is nothing? It's because we have end minus begin is equal to 1. Okay, all right. So if this is true, then I'll return 1. Okay, else I'll return 0. It means that region of interest in the region of interest you don't have k. Alright, what if this is also not true? Okay, if end minus begin is greater than 1, okay, is equal to 1 is taken care of, is equal to this thing is also taken care of. I mean, end minus begin is equal to 0 is also taken care of, is equal to 1 is taken care of. What if it is 2 or more? That's what I'm taking care of here, right? That's pretty easy. Let's see what happens. If it is more than this, then I do, what do? I compute mid. You see, mid is end plus begin plus end divided by 2, right? Correct. So no comments anywhere, so let me just write comments here. If begin and end are the same, then we need to just check L of begin. Okay, that's what we're doing here. Okay, if begin and end are consecutive means one next to the other, then check them individually. That's it. But what if end minus begin is greater than 1? By this all I mean is, what if you have begin here, end here, and you have at least one element in between these two things, and this becomes your region of interest, right? Then these two cases are not true. We may have to search through it. You see, remember in recursion we have the trivial cases and then the not so trivial case. This is a not so trivial case. Okay, middle equals begin plus end by 2. By this, what do I mean by this? Compute the middle element. Okay, L of mid will be the middle element. If L of mid is greater than k, what does it mean? Just like you all, even I'm blank at times. Okay, by this I mean, you may not be blank, I didn't mean to belittle you. We generally think on the fly. I mean, we go slowly and we may not know everything as we are coding, right? So what is this? K, if L of mid is greater than k, which means middle is, let's say, this. Okay, and L of mid, whatever is here, this is greater than k. This is greater means what? K should be in this zone. Okay, and this part should be discarded. All right, so let me write that down. Discard the right, retain the left. Discard the right, retain the left. Discard the right, retain the left. Okay, discard the right, discard the right, and retain the left. Okay, that's what this means. If L of mid is greater than k. How do I do that? That's very easy. I simply say, how do I discard the right, retain the left? Begin remains the same. Your end becomes mid minus 1. That is how you retain the left. Okay, and discard the right. We have discussed this, right? And what if this is not true? If L of mid is less than k, then discard the left and retain the right. Okay, yeah, don't worry about this. Okay, so yeah, fine, so far so good. So this takes care of the situation where L of mid is greater than k, L of mid is less than k. But what if L of mid is equal to k? Then hip hip hooray. What I do here, I should write this, right? How do I discard the left and retain the right? I discard the left by saying my begin is equal to mid plus 1. Correct? That's only obvious from our previous case. I mean, from our previous program, we have been seeing this. This is all in our mind right now. Anyways, so I'll just tell you what's happening here. Whenever I save it, it says there's an error here because the code is incomplete. This is how I have configured it. And I say L close and this closes. But don't worry, in your editor, this may not be a problem. I should stop saving this as often as I do. Alright, so L of mid is equal to K means what? I am done. Return 1 and yeah, back home. We are done. It's over. Right? If L of mid is equal to K. Right? If it's less than K, then you retain the right. If it's greater than K, you retain the left. Okay? Good. So what do we do next? This is not a while loop. This is just an if loop. All I do here is I return the function right now. What's the function? I should return the function R binary search LK begin and end. My begin and end has changed right now. Okay? Return R binary search L and K with my begin and end. These two are now different. Okay, now I save and there's no error. Alright, so let me just think through it. Am I right? What is the situation? What is the case when end minus begin is negative? Can that happen? It can as well happen, right? When you end up saying end equals mid minus 1, you're decrementing mid. End may become less than begin also at times, we don't know. Alright, so maybe we can write another condition here. Say if end minus begin is less than 0. Okay, we have greater than 1 is taken care of, is equal to 1 is taken care of. This is equal to 0 basically. End minus begin is equal to 0 is this, as I keep saying. Okay, but end minus begin is equal to 0 is weird way to write it, so I write it as begin is equal to end. Okay, so if end minus begin is negative, okay, then no, you have not found, right? That's what it means. End minus begin is negative means what? What does it mean? End begin should be here, end should be here. When end comes this side and begin comes this side, it means that there's no region of interest at all. Right? So what I do is I should return 0. I hope this works. I have no clue. Let us see now. Alright, this again, the entire code I have typed it on the fly. Every possibility there will be some errors, but let's see. Okay, let me reduce the font size just so that you can see both the sides. Import R binary search. Good. R binary search and R binary search. Put some list 1, 7, 10, 16, 100, 108, 1008, so on, and search for the element. Let's say I'll search for 7 here. Begin should be 0 obviously. End should be the length of this list, which is 1, 2, 3, 4, 5, 6, 7, which is 6, right? Length of that minus 1. Okay, good. It gives me the answer. My code seems to be right, but what if I type something that is not here? Okay, it is not there. Wonderful. My code is working really well. Good. Now let us do the same old. My list is equal to list of, what is that? Range of 100 million. If you're wondering why I write it like this, it's easy on the mind. 1000 times 1000 is million, times 100 is 1 million. We all have our own style of doing a few things. This is my style. Okay, you may find it very silly though. Alright, so that computes it. You can even do it for a billion. If you remember, last time we did it for a billion, it took its own time. It took months to stop. So I won't try it for 1 billion, I'll try it for 100 million. Okay, so I am now going to search for R binary search on my list L. I want to find the number, let's say 1 million, which is there in the list, by the way, starting from 0 and ending. My end is this. Why? Because we saw in the previous video. I'll not get there. I mean, it's very easy. This is begin and end. You start from region of interest 0 to the entire list basically. Then boom, it's very, very fast. You see, very quickly it gave me the answer. But is it better than the obvious search? So let us put something that is not there. Obvious search will take eternity. You saw that it takes a few seconds, but beautiful. It very quickly says, no, it's not present, as you can see. Alright, wonderful. So we use recursion to solve the problem. As you saw, it's actually easy on the mind. If you still think even I am stumbling, programming involves programmer to stumble. Nobody confidently writes a piece of code. I think 10 years from now, if I keep coding the same program for binary search recursively, I will still stumble a little. That's how programming happens. You just think logically. That's not so straightforward. Right? It's okay to stumble here and there and slowly build logic. Okay, good. So what have we seen? We have seen a recursive program for one second. Let me just open it. Okay, so we just saw a recursive code for binary search. Okay, we also saw a non-recursive code, and with the help of that we built a recursive code for binary search. We use recursion, a very powerful technique, to illustrate. It can actually be easy on the mind when you use recursion, right? As and always, please practice, and practice. Try writing this code all by yourself. Alright, first time when I write it, it may sound very difficult, but trust me, all that we did was very, very obvious. It is as simple as referring to a dictionary, right? How is it referring to the dictionary? Let me illustrate. How is this referring to the dictionary? It's because in a dictionary, if there are 1000 pages, the problem of finding a word in 1000 pages is same as the problem of finding in the first 500 page after you have realized that you have discarded the other 1000 pages, right? The problem now boils down to you finding the word here, and then again you just halve it, okay, and discard one half, depends on where the word is, right? And this will become your region of interest. Okay, and then again that gets halved, and so on and so forth, right? Recursively you argue here, and that's precisely what we did just now. I hope it was clear. If it was not clear, please see the code once again, redo it as I am explaining. You type it, open the terminal, and then do it. You will have errors, you will have lack of clarity, but with time you will achieve clarity. Thank you very much. That ends this week's discussion with recursion. I only have a small thing to illustrate right now, which I'll illustrate very quickly. The dangers of recursion, especially in Python. Okay, so let me zoom this, clear this, reset this. Okay, so you remember we tried sorting using Python, okay, and recursively, right? We tried defining sum of n numbers, okay, and we used recursion to do this. How did we do it? We started off with how was that? We said if n is equal to 0, then return 0, right? Else return n plus sum of n minus 1. Okay, let's see if this works or not. Sum of 10 is 55. Beautiful. Sum of 0 should be 0. Sum of 1 should be 1. Sum of 2 should be 3. Sum of 3 should be 3 plus 2 plus 1, 6. Sum of 4 should be 4 plus 3 plus 2 plus 1 is equal to 10, and so on and so forth. Right? Now see what will happen when sum of 900 is computed. Oh, it gives the answer. Very good. Okay, zoom in. Okay, what happens if I say 950? It computes the first 950 numbers and gives me the answer. What if I say 990? It works, right? 999, it works. What if I say 1000? It works. 1001 works. 1002 works. 1003 works. When I say sum, let's say how much? 100,000, it says maximum recursion depth exceeded in comparison. You cannot go on like this, right? There is a stage after which it cannot do more recursion. Okay, on your computers, the limit by default is 999. Okay, I was expecting that here too, but it went beyond a few, beyond the actual recursion limit. All right, but otherwise the recursion limit is simply 999. In fact, this will not work on your computer. When you say sum of 1000, it will spit out an error. Right? So what is it that I'm trying to say? I'm trying to say that recursion will not always work in Python. Okay, beyond a limit. The default limit is actually 999, but you can change this. It's very easy to change. I don't want to get into the technicalities. It's pretty easy. It's just a one-line command. You must basically import a function called sys, a library function called sys, and then there's a one-liner command. Okay, you figure it out, but then point to note, recursion cannot go on and on. In binary search, we used recursion. It did not cross the limit, so it worked well. If it crosses the limit, it will throw out an error, which is okay. This is purposefully done because recursion sometimes can keep going on and on and on and on and not stop. So Python puts a checkpoint that 999 is the limit. You better know it, says Python. Okay, if you want more, you must change it. You must meddle with the settings and then change the depth. By the way, you cannot change it to infinity because you cannot change it to infinity for a simple reason that you are limited by your computer resources, right? I mean, so you cannot go beyond what your memory can permit. Recursion is a very complicated process. It's important for us to put this is called the nudge effect. Purposefully, you limit. So the idea is, assume you're working on your calories. I ensure that I don't give you beyond 1000 calories. You come for dinner, I say, look, 1000 calories are done now. If you want more, you must give it to me in writing that you want more food. It's very mean for me to do that. I'm just giving you an analogous example, right? That's what Python does. It doesn't let you go beyond a limit. Didn't understand what I said? Don't break your head much. If you understood what was binary search recursively, that should be more than enough. Right, let me exit the terminal and bid bye to you all for this week. We are done with recursion. We are done with binary search. I had to do file handling, but we have covered quite a bit right now. I'll skip file handling and do it the next week. So time to say thank you all very much. See you next week. Bye bye.